Today's lesson is on radical equations, and this will be log page 17 in your logbook. Our objective for today is to solve equations with variables under the radical sign. A radical equation is an equation with a variable underneath the radical sign. On the left-hand side of your screen, I have three examples here of what radical equations look like. Please notice that with these three equations, there's a variable underneath the radical sign. Right here, the 1/3 power is the same as the cube root, so this variable is under the radical sign because this is the same as the cube root of 5n minus 1. These are all radical equations. On the right-hand side of your screen, we have three equations that have radical signs in them, but in each one of these, there is no variable under the radical sign. The variables in these equations are outside of the radical sign. So these are not radical equations. Let's look at how we're going to solve and verify radical equations. In example 1, we have a radical equation of the square root of x plus 1 plus 2 equals 4. In our how-to steps, it says to isolate the radical first. Okay, here is my radical. I need to get it by itself. So I need to remove this 2 that's being added to the radical, and we need to get it to the other side of the equation. And the way that we do that is by subtracting 2 from both sides of the equation. When I subtract 2 from both sides of this equation, then what that does is it isolates the radical. Because 2 minus 2 is 0. And on the other side of the equation, I have 4 minus 2, which is 2. Now I have my radical all by itself. The second step says to raise both sides to a power equal to the index. The index here is an understood 2. So let's raise to the second power. Raise both sides to the second power. The reason that we do this is because squaring and square rooting are inverse operations and they undo each other. So when I square a square root, it undoes the square root and I'm just left with x plus 1. On the other side, I have 2 to the second power, which is 4. Now I have a linear equation that I can solve, and step 3 says to solve the resulting equation. So here, to get rid of this plus 1, I'm going to subtract 1 from both sides of my equation, and that leaves me with x equals 4 minus 1, which is 3. Now I think this is the answer to my problem, but I've got to verify it. So I'm going to go back to my original equation, the square root of x plus 1 plus 2 equals 4. And everywhere I see an x, I'm going to substitute my answer. So I have the square root of 3 plus 1 plus 2 should equal 4. The square root of 3 plus 1, that's the square root of 4. The square root of 4 is 2, and 2 plus 2 is 4. So I have now verified that this is the correct answer. Let's look at another example. A second type of example might look like this. The square root of x plus 15 equals the square root of 2x minus 3. Now on this problem, I have two square roots, and they're both already isolated because they're on opposite sides of the equal mark. So the first thing I'm going to do here is raise both sides to a power equal to the index. In this case, my index is 2, so I'm going to square both sides. So squaring undoes the square root, so I end up with x plus 15 equals squaring undoes the square root, so I end up with 2x minus 3. Now I have a linear equation that I know how to solve, so I'm going to subtract x from both sides. X minus x is 0. 15 plus 0 is 15. Equals 2x minus 1 is x, and then this negative 3 plus 0 is negative 3. So 15 equals x minus 3. Now to get rid of this negative 3, I'm going to add 3 to both sides, and I end up with x 18, I'm sorry, equals negative 3 plus 3 is 0. X plus 0 is x. So 18 equals x. Now let's verify. So we're going to take our original equation, and everywhere I see an x, I'm going to substitute 18. So the square root of 18 plus 15 equals the square root of 2 times 18 minus 3. So 18 plus 15 is the square root of 33. 2 times 18 is 36, and 36 minus 3 is 33. So the square root of 33 equals the square root of 33. So I know that I have the correct answer. All right, let's look at another example. In this example, let me scoot this down. In this example, you might look at it at first and say, wait a minute, I don't see a square root. But hopefully you remember from yesterday's lesson that this exponent of 1/2 is the same as a square root. This is a square root because it's a fractional exponent of 1/2. All right, so the first thing that we have to do, and my document camera just focused, I apologize. The first thing that I have to do is isolate the radical. Well, here's the radical right here because it's that fractional exponent. This is what I need to isolate. So first thing I need to do is get rid of this negative 2 by adding 2 to both sides. So now I have negative 2 times 4n minus 1 to the 1/2 power, and that's going to equal, because negative 2 plus 2 is 0, that's going to equal 2. Now I'm still trying to isolate my radical, so I have to get rid of this multiplication by negative 2. So I'm going to divide by negative 2. Negative 2 divided by negative 2 is 1, so that leaves me with 4n minus 1 to the 1/2 power is equal to negative 1. Now at this point, you might notice that you have a square root equal to a negative number, and that might send up a little red flag for you. But if it did not send up a little red flag for you, then you would probably just keep on simplifying this. Okay, and we'll come back and talk about this little red flag in a moment. At this point, you've isolated your radical, so now you're going to raise both sides to a power equal to the index. Well, the index here is the denominator, so that's a 2. So we're going to raise both sides to the second power. Remembering that when we raise a power to a power, we keep the base and we multiply the exponents. Well, 1 over 2 times 2 over 1 is just 1. So that's 4n minus 1 to the first power, which is just 4n minus 1, equals negative 1 squared is negative 1 times negative 1, which is positive 1. And now I'm going to solve the resulting equation. Well, I've got to add 1. So I get 4n, because that's 0, equals 2. And then I divide by 4. Divide by 4. N equals 1/2. Now what I need to do is verify that this is the correct answer. Okay, this original equation is negative 2 times 4n minus 1 to the 1/2 power minus 2 should equal 0. Scoot over just a little bit. And I'm going to put in 1/2, substitute that in everywhere I see an n. So 1/2 goes right here. So let's start from the inside. 1/2 of 4 is 2. 2 minus 1 is 1. This means the square root of 1, which is 1. If you want to look at it this way, you can. This is the square root of 1, which is 1. So negative 2 times 1 is negative 2, and negative 2 minus 2 does not equal 0. It equals negative 4. So negative 4 does not equal 0, So this is not the right answer. This is what we call an extraneous solution. And when you raise a power, or when you raise both sides of an equation to a power, then you run the risk of finding extraneous solutions. These are solutions that will solve this equation, but not necessarily solve the top equation that we started with. When you have an extraneous solution and it doesn't work, then there's no other solution to choose from, then you say no real solution. And again, if you want to use this symbol, you can. Now, right here, the little red flag, hopefully we would have realized that I can't take a principal square root and get a negative number. And if you realize that, then you could have stopped right here where the little red flag is, and you could have said no real solution. But if you didn't realize that, you just go ahead and solve it, and you'll find when you check your work that there is no solution. All right, let's look at another example. This example is a cube root. The cube root of 2x minus 1 equals negative 2. Now I can have a cube root. I can have an odd index equal a negative number. That's okay. So let's raise both. This is an isolated radical. So we're going to raise both sides to a power equal to the index. Since the index is 3, we're raising to the third power so that the cubing and the cube rooting can undo each other. And that just leaves me with 2x minus 1 equals negative 2 to the third power is negative 8. And then I just solve the resulting equation by adding 1 to both sides. Negative 1 plus 1 is 0, dividing by 2, and x is equal to negative 7/2. So x is equal to negative 7/2 here. Now we've got to verify that this is the correct answer, so we're going back to the original equation, and everywhere that we see an x, we're going to substitute negative 7/2. So this is the cube root of 2 times negative 7/2 minus 1 equals negative 2. This is 2 over 1. So this is the cube root. 2 over 1 times negative 7 over 2 is negative 7 minus 1 equals negative 2. Negative 7 minus 1 is negative 8. And we know that the cube root of negative 8 is equal to negative 2. So we know that this then is a valid answer, and it is the correct answer. And let's look at one last example just to make sure that you have this down. We're going to solve and verify 3 times 5n minus 1 to the 1/3 power minus 2 equals 0. So we're going to isolate first. So we're going to add 2. And we're going to get 3 times 5n minus 1 to the 1/3. This is 0 equals 2. We're going to divide everything by 3 to get rid of this multiplication by 3, because 3 divided by 3 is 1. 5n minus 1 to the 1/3 is equal to 2/3. Now we're going to raise everything to the third power, because this is the same as the cube root. The index is 3, so we're raising to the third power. So this is 5n minus 1, because 1/3 times 3 is 1, so that's the cubing undoing the cube root. And then this is 2 cubed, which is 8, divided by 3 cubed, which is 27. And now in order to in order to isolate the n, we're going to add 1 to both sides. Negative 1 plus 1 is 0, so that's 5n equals 8/27 plus 1. You can go to your calculator and do this, but 8/27 plus 1 is the same as 27/27. So I'm going to add 27/27 and 8/27, and that is going to give me 35/27. And then, since I have a fraction over here, instead of dividing by 5, that's the same as multiplying by the reciprocal, which is 1/5, so that these still cancel and I get n. Multiplying by 1/5 equals 5 goes into 35 7 times, so that gives me 7/27. All right, now we can go back and verify it. And on this one, if you wanted to verify it in your calculator, you certainly could do that. I don't have a problem with you verifying with your calculator. So let's look at how we can do that. Pull my calculator up here and put it underneath the document camera so that you can see it. Let me clear that. So what I'm going to do is type in the original equation, which is, let me see if I can move this so you can see it a little better. There, that's better. 3 times 5, and my n is 7/27. 5 times, and 7/27 minus 1, close my parentheses, raised to the 1/3 power. Now I have to arrow down out of my exponent, and then minus 2. And then I hope that I get 0, because if I do, I know I have the right answer. So I've verified with my calculator now that this is the right answer. All right, guys, I've missed seeing you for 3.5 days, but I will be back tomorrow. So we'll start going over, and we'll review all of this on Friday. Then we're going to review for a test on Monday. We'll review on Monday for a test, and the test will be on Tuesday. So please be sure you've looked at these videos, make sure you've taken your notes, and be sure you're doing your homework.